Hey everyone, my name is Johan and I work in the JavaScript advocacy team here at Microsoft. And in this session, we'll see how you can build your generative AI apps starting from your local machine up to Azure using LangChain.js. We're still at the beginning of exploring what you can do with generative AI, and the field is moving very fast. And when things move fast like this, you need to be able to experiment and iterate quickly. First to validate your ideas with a prototype, then to scale up to production if it works. That's why we committed to give you the best and quickest path for developers to create new AI experiences by providing building blocks and frameworks integration where you can easily plug in your data and services. For example, native Azure OpenAI support was recently contributed to the OpenAI Node SDK, meaning it's now very easy to move from one to the other. As you can see, it's in the regular OpenAI SDK. Now going back to the demo. If you're building an AI application, you don't want to start from scratch. Here, we use LangChain as our LLM orchestrator, Ollama to download and run local models easily so we can experiment a bit. And finally, we used Azure for the OpenAI models and Azure AI Search as a vector database that we'll use for deploying the final application. So using local models allows you to experiment quickly at no cost, and here we use the Mistral 7B model to build our prototype. With Ollama, you can run your models interactively, just like a sort of minimal ChatGPT right from your terminal, but also use it as an OpenAI compatible API. So just asking a quick question, just like your regular chat experience, I can get directly an answer, and here I have the model running fully locally on my machine. Now let's have a look at the application we've built. So this is the final deployed application. For the Contenso real estate company, we've built this experience that allows customer to ask support questions about the usage of its products. So here you're looking at the final deployed version on Azure that use a set of company documents to answer the questions. So this is using serverless functions, so the first time there's some warm-up. So we can see the source PDF here that were used to create that answer. And then at the end of the answer, we also suggest some follow-up questions that the users may want to ask next. Now, the interesting part is how we built this. So, going back to the code, you can see that we have many instructions for the prompt. Here, we're using Retrieval Augmented Generation or RAG to ground the answer in a set of PDF documents. You can see the documents in the data folder in there. But before coming up with this completed prompt, we had to experiment a bit to get the result that we wanted. And this is where we used a local LLM and a local vector database. So moving back to the code. Here you can see the part where we run the code locally. And then once we got the result that we wanted, we switched to Azure OpenAI GPT-4 Turbo model and Azure AI Search for better relevance and performance. And to do that, we only had to replace these few lines that initialize the models and the database thanks to the Azure integration directly in LangChain. So now actually, let's first test the application running locally. You've seen the deployed version. So let's show you how the local version runs. So switching back to localhost, so this is the same application, but this time running locally. Let's try a different question in there. So we can see that we still get a response. We get follow-up question, but there's a small glitch in there, like it added maybe like the number of the section, making the PDF link not working. if I try to click on it. So yeah, local models are good enough to show that our approach works, but sometimes it has glitches like this. And yeah, it's expected from a smaller 7B local model, and it's totally fine for development and experimentation. Now this time you see that it even generated the wrong citation. That's also why for production we switched to the state-of-the-art GPT-4 Turbo model, because what we want is our app to work perfectly every time for our customers. So now that we have a fast working inner loop and we know that we can switch to production deployment easily, to build your own AI chat like this one, we're providing a set of building blocks that you can reuse. Let's have a look at what we have here in our package.json file. You can see that we're using the Azure SDKs in there, but we are directly using the LangChain integration that we have for OpenAI. And we also have this AI chat protocol package that provides an API specification. You can have a look here at the repo. This specification is open source, and it allows you to mix and match the building blocks from different samples, for example, using our Python AI chat backend with the web app frontend for this demo, and we also have an NPM package for that. We also provide full features standalone web component in there that's compatible with any backend following the AI chat protocol specification, so you can use it in any app that's following the AI chat protocol. So now talking about the infrastructure part, as developers, we know that it's not really like the fun part. And all our AI samples, including this one, also include full infrastructure as code. If you look into this infra folder, you can see a set of templates. And this is also important because, yeah, we care a lot about security. And oops, I've just shown you my .env file. But you know what? That's okay, because if you look closely, there's absolutely no secrets in there. That's because we used Azure Managed Identity. It allows to use role-based access control for all the Azure services that we use, so no secrets are needed anymore. And now it's your turn to build your own generative AI app. We also have some links to everything that we've shown during this demo, including the code for this sample app and the various building blocks that you can use.